Good morning, students. Today we will learn about muscle contraction, an essential process for movement, posture, and breathing. Muscles contract to produce force and enable us to perform various actions like walking, running, and lifting objects. There are different types of muscles, skeletal, smooth, and cardiac. But today, we focus on skeletal muscle, which is voluntary. Let me draw the structure of a sarcomere on the blackboard, as it is the basic functional unit of skeletal muscle. A sarcomere is bounded by two Z-lines, which are disc-like structures that anchor actin filaments. Inside the sarcomere, we see the I band, which contains only actin filaments, and the A band, where both actin and myosin overlap. There is a central region in the A band called the H zone, which contains only myosin filaments, and a M line in the middle, holding the myosin in position. Now let's understand the sliding filament theory step by step to explain how muscles contract. During contraction, the myosin filaments slide over the actin filaments, shortening the sarcomere, while the A band length remains unchanged. This sliding action causes the I band and the H zone to shrink as actin and myosin filaments overlap more. The key roles in contraction are played by actin, myosin, ATP, and calcium ions, Ca2+. Actin has specific binding sites called myosin binding sites, which are usually covered by a protein called tropomyosin. Myosin is a motor protein with heads that attach to actin binding sites when exposed, forming cross bridges. ATP provides the energy needed for both the attachment and detachment of myosin heads during contraction and relaxation. Calcium ions, Ca2+, are released from the sarcoplasmic reticulum and bind to troponin, causing tropomyosin to move away from actin binding sites. This exposes the myosin binding sites, allowing myosin heads to attach and pull actin filaments, resulting in muscle contraction. During muscle contraction, actin and myosin slide past each other, and the sarcomere shortens, producing a pulling force. Muscle relaxation occurs when calcium ions are pumped back into the sarcoplasmic reticulum. Tropomyosin covers actin sites again, and cross bridges detach. The role of the sarcoplasmic reticulum is crucial, as it stores and releases calcium ions when needed for contraction. In summary, during contraction, the I band and H zone shorten, but the length of the A band remains the same, which is an important NEET point. Remember, ATP is required for both muscle contraction and relaxation, and calcium ions enable actin-myosin interaction. If you understand the structure of the sarcomere and the sliding filament process, muscle contraction will become very clear for NEET.